I'd like to thank all three speakers. I think you have a vision of the future. Some of it is here now, but the opportunities are very exciting. With that, I'd like to open it up to your questions. Each of the panelists has a microphone and can respond. So are there questions of the panelists? Oh, no, they're recording it. If you could get to them, I'm sorry, get to the microphone.
Question to Dr. Holdish. Would you explain to us novices that are just hearing about these novel and interesting ideas for the first time exactly how you get gas, why is it in the rocks, how is it removed from the rocks, and is it replenished, or once you remove it from the rocks, is the gas field no longer effective? What holds it in the rocks?
Okay. The natural gas is formed in situ from plant material, algae and plant material, and as it's buried and it's heated up, it converts into kerogen, and then kerogen converts into oil and gas, and it's trapped in the reservoir due to either some sort of impermeable barrier or capillary forces, and so some of that gas migrates out, and it migrates due to gravity to another structure that traps the gas, and these are the conventional reservoirs we've been developing for 150 years. But what we found out is these source rocks that are the source of all the oil and gas still have a lot of gas in them, and once it migrates out or once you produce it, it's gone. It doesn't keep generating, but it's in the process of being generated right now, actually, in a lot of these reservoirs.
Very good. And can I ask Dr. Swift a question quickly while I'm here? What criterion, you mentioned most of the wind turbines are in western parts of Texas. I think we can understand there's a lot of wind there, but what criterion goes into establishing a wind turbine field, and why not use the Gulf as opposed to the mountains?
Yeah, good questions. The criteria is, first you want the wind resource and access to it, access to transmission. Flat land is a little bit easier than the mountains, and that's why I mentioned that, to keep down the installation costs. Excellent question on the Gulf. I should have emphasized that on the resource slide. Texas is blessed with not only good resources in West Texas, but also coastal resources. And I think we're talking and partner with folks at A&M. They've established a wind energy center, and there's going to be some opportunities probably from DOE for us to get in that. And of course, Texas has a great history in offshore. I mean, I think we're really poised to make a difference close to centers. The winds aren't quite as energetic there, but the timing of the winds are very good. They fit better the demand for electricity. So, thanks.
Thank you. Dr. Shine?
I noticed recently a willingness for Texas to accept low-level nuclear waste in terms of disposal. And I'm curious as to whether the group feels that a proven source of power, namely nuclear power, whether its availability in really meeting the states and the country's needs is principally a political sociologic phenomenon, or whether you think technical innovation is in fact a rate-limiting step in terms of the ability to actually adequately use nuclear power.
Let me take a whack at that. I think one of the biggest problems for nuclear power is cost. The cost of a nuclear reactor site is being undercut by the inexpensive value of natural gas. Natural gas can produce electricity cheaper than nuclear can now. Dr. Holdish, would you like to comment on that?
I'm not sure about that.
Yeah, with natural gas, I don't know what it is now. Is it $3 a million BTU?
About $4.5.
$4.5. My numbers are something like $8 a million BTU for, as I understand it, for nuclear to be competitive. It's an issue of cost of licenses and et cetera, and the time and so on. Was that an answer to the question?
Is the cost a technological challenge, or is it primarily a physical and/or policy challenge?
It's, from what I understand, and do we have nuclear energy experts in the audience? Maybe they can help. My understanding is that the current licensing process just makes the cost exorbitant because of the length of time it takes to go through the permitting process. But perhaps there are professionals here who could comment on that and know better.
Let me say one thing, and then we'll go to that. When you're looking at the energy, you have to have a base load, something that's on all the time, putting out electricity, and right now we're using either nuclear or coal, and because you can't just turn nuclear plants or coal plants on and off, they have to run, and so I think it's a policy decision. If we want to get rid of coal and use nuclear, we could do it, and then the clean energies, the solar and wind, are intermittent. So you've got to have something to offset the intermittent part of the wind and solar, and that could be natural gas. So as Rex Tillerson said several times this morning, it's all of the above. We need a base energy load, we need wind and solar, and we need natural gas to fill in the gaps. And so I think it's a system engineering problem, and we're going to have to build the smart grid, the systems, the computers, the sensors to control all of this. And I think the coal will be driven out of the market if the environmentalists push on it hard enough.
The next question.
Sure. Hi, I'm Cara Kaufman at University of Texas here in Austin in civil engineering. So my question is for Dr. Swift. It's really two questions. It's interesting to me that at night that we have the higher wind speeds, and I assume that has to do with ground temperatures. I'd be curious, and I imagine for forecasting that we need, in order to know at what level to run the other plants in the system, you're going to need a lot of sensors spread out spatially. I'm just curious if that's accurate. And then my second question is the transmission losses have constrained some of this, and I'm wondering, is that still about 10% of the power is lost over a 500-mile distance, and is that coming down? I'm wondering what innovations are driving the reduction in losses of power over distance.
Okay, I'll try and take those in reverse order. I still walk around with a rule of thumb of 10%. Of course, it is a function of distance. There are some innovations coming with high voltage, higher voltage lines and DC lines to try and move large amounts of power more efficiently. So I think that's the point. On the forecasting, yes, you need sensors. And we run a West Texas mesonet. We have 50 stations in the area, and the more stations you have, the more accurately you can run these forecast models. I don't think we have forecast models that are sufficiently robust and of high enough fidelity to do the really accurate kind of forecasting that we're going to need in order to successfully integrate wind into the system. Steve made a really good point here. It's a systems problem. It's really a systems problem.
And the higher speeds are due to ground temperatures? Is that why at night we see those? Or?
I'm not a meteorologist, but as I understand, it's an artifact of the Rocky Mountains, the flatness of the Great Plains. The way our weather works in the country makes the Great Plains kind of the wind energy basket of the country.
Right, but at night?
Yeah.
I think Dr. Swift put it very well. If you think predicting the weather is hard, just try wind. And those of us who listen to the weather forecast the day ahead of time know how accurate that is. Next question.
Well, I had a quick compliment, comment, and question. The compliment is Ray and two other fine gentlemen exported out of Texas to the Department of Energy. Thank you for your service. It's the other Texas human capital that we talked about today, so thank you for that. My comment and question, since I know a little bit about energy, and I live in New Hampshire, and we have the problem that our states are so small and there are too many governors to agree on anything when it comes to transmission. So because you have your own grid and you've got some exemptions from FERC, What I didn't hear today is a bit about the innovation around the transmission of power. The Chinese are taking Western Europe and US innovation and building the longest haul, highest voltage, most efficient DC transmission lines that man has ever built. And so I just wanted to add, in the spirit of energy innovation, that there is the potential for Texas to also not be the showcase only for wind and possibly for solar out in the West, but perhaps because of the unique political situation here and the large geography of Texas, to be a showcase for America and the world in implementing in America the state-of-the-art of transmission with these super high voltage DC lines from western to eastern Texas. And I hope you take that innovation and challenge and as a showcase for America and the world as well.
Dr. Swift, did you want to comment on the DC transmission prospects?
Not really. I think we commented on it briefly before. I mean, that's a huge issue, is moving the power from the Great Plains to load centers, and I think there is some effort to do that, but I don't think at the scale that that gentleman was talking about.
Yes.
I'm Jim Tour from Rice University. I agree with you that hydrogen is a very good way to go. First from natural gas, the conversion to hydrogen, and CO2, because the CO2 is made at the plant. And then in the long term, looking at the conversion from water. I think that what's important is that coal has to play a part. And I have no personal stake in this game. I'm just saying that it's going to be politically untenable to start cutting out sectors of the country where this is really valuable. And what we can continue to do with coal, which we do to some degree, is make syngas, make hydrogen and CO and convert that further on to more hydrogen with water and CO2 and move things toward that hydrogen economy. Because if we think about just cutting out sectors, after coal gets cut out, natural gas will be next. And so what we want to do is use this as a transition and use the coal for generating hydrogen and use the natural gas for generating hydrogen as we learn how to use that and transition that to where we can then come up with a methodology, a good methodology to take sunlight and water and create hydrogen from that, and then use that hydrogen to make CO2 into a valuable product so that when it has value, because we could take we can take water-generated hydrogen, reduce the CO2, and convert that then to methanol. Then the CO2 has value to us, and we don't just want to blow it out in the air.
Dr. Bard, did you want to comment on that? Let me ask the follow-up to that question. What is the time scale in your view for sunlight to fuel?
Okay, well, let me go backwards. I don't think one really knows in terms of a practical system. We've been doing it for 40 years. The system works, but it's not scalable and so on. So I don't think I can give you an answer for that. To Jim's question, I think he's right. I think no one is going to abandon coal or our current sources because you have to ask the question at every point, what do you put in its place? There was an interesting study done on the Indian Point nuclear power plant in New York where people were very, very opposed to it. It was an old plant. Where are they going to recommission it and so on? They asked NRC for a study. NRC looked and told them all the possible alternatives, none of which were as good as nuclear. So a coal plant, you just can't get hydroelectric and solar and replace a coal plant at one shot. So I think it's true. Coal will be there. Coal may be a source of hydrogen generation. I think it will be natural gas much before coal. But eventually, I think it will have to be replaced.
Let me, in defense of coal, refer you to the Tenesca plant in southern Illinois and the battle that's currently going on there over hydrogen generation from coal. It's an oxy-combustion system. It's one very expensive operation. So what Professor Bard is looking at is hopefully an alternative for hydrogen production. Yes?
I'm Bob Curl from Rice. This is a question I think Ellen has heard me ask for someone previously at the Welsh meeting, but I've never understood why anyone would want to make a single package that involved both the generation of hydrogen and the absorption of light and the generation of hydrogen in the same package, since you can create electricity with equal efficiency and move it to wherever you want to use it to electrolyze water.
Well, I think it's a question of two things. One is capital cost. If you could build a single system without having the capitalization of a photovoltaic plus an electrolyzer, you can get a much more cost-efficient method. And the second is moving it, as we heard, you lose. So if you generate hydrogen on site,
Yeah, but you don't have to move it but 3 feet, say.
Well, it depends how you want to do it.
Yeah.
But I mean, it's probably more efficient, in fact, to generate hydrogen and pump the hydrogen in a line than it is to move electricity.
Which is an interesting comment, that sunlight to fuel may be as much a storage issue for energy as energy itself. Last question.
Rick Barrera, also Rice University. You represent a number of what I'll call energy capital within our state, and some others have been mentioned. And my question I'll ask, and I have other comments to go along with it, is where's the intersection of each of these different energy areas? Where is that, and how does that come together? And so what I mean by that is, how are you communicating with each other so that we as a state, because we have the potential in Texas to raise our research capital through energy, and likelihood is that we should be doing a strong communication between these different entities. Where is that happening, and what's the process going on, or is it happening?
Dr. Holditch, did you want to try that?
Well, I don't know. That's the answer to that. But I can tell you we're going to have the TAMEST is going to sponsor a Texas Energy Summit in April, and we're going to try to get together 100 of the top leaders in Texas from academia, industry, and government, and we're going to try to start the process of coming up with a Texas energy plan. How are we going to take all these diverse sources and pull it together and try to set some guidelines, some ideas on what our state leaders can do to make sure this state has abundant, clean, cheap energy for the foreseeable future. And that's going to be essential to our progress and our development. So I think TAMEST is going to try to take the lead on that, but we'll just have to see. We're going to focus a lot on energy this year at TAMEST.
The question, of course, has its echo globally and especially nationally. Does the United States have an integrated energy plan? And you all know the answer to that. With that, I'd like to thank our three speakers very much, and also the audience for your participation. Thank you all.
Excellent presentation.